Welcome to today's lesson on the forces at play during a star's main sequence stage. Today, we will understand the process of nuclear fusion in main sequence stars. Next, we will explain the balance of forces in main sequence stars. So far, we have explored the life stages of stars that are the same size as our Sun and stars that are larger than our Sun. Building on this understanding of a star's life cycle, we will delve deeper into the main sequence stage. This lesson will advance our understanding of physics by explaining how the delicate balance between gravitational attraction and radiation pressure from fusion governs a star's stability and longevity. Let's get started! Main sequence stars are the most abundant stars in the universe. Our Sun is a prime example of a main sequence star. During this stage, the star is in a state of equilibrium where two main forces are at play: radiation pressure and gravitational attraction. In the star's core, hydrogen atoms are squeezed together under immense pressure and temperature. This squeezing is so intense that it leads to a nuclear reaction known as fusion. Inside a main sequence star, the core is extremely hot and dense. Under these conditions, hydrogen nuclei, which are protons, combine to form helium nuclei. The basic fusion reaction can be summarized as 2 hydrogen nuclei creates 1 helium nucleus plus energy. Importantly, the mass of the resulting helium nucleus is slightly less than the total mass of the original hydrogen nuclei. This tiny difference in mass is converted into a huge amount of energy, according to Einstein's equation, E equals mc squared, where E stands for energy, m for mass, and c for the speed of light. This energy produced in the core creates an outward pressure called radiation pressure. Radiation pressure acts like a force pushing outward from the core of the star. This outward force is crucial as it counters the force of gravity trying to compress the star. Now let's consider the role of gravity. Gravity is the force that pulls objects towards each other. In the case of a star, gravity tries to pull all the material in the star inward toward the core. Gravity exerts an immense inward force due to the massive amount of material in the star. Without any opposing force, gravity would cause the star to collapse in on itself, leading to a much smaller, denser object. However, the radiation pressure from fusion provides an equal and opposite force to gravity. This balance keeps the star in a stable condition, neither collapsing under gravity nor blowing apart due to the fusion energy. This equilibrium is why main sequence stars, like our Sun, can shine steadily for billions of years. In today's lesson, we delved into the forces at play during the main sequence stage of a star's life, focusing on the delicate balance that maintains a star's stability. We discussed that main sequence stars, like our Sun, are in a state of equilibrium due to two main forces: radiation pressure from nuclear fusion and gravitational attraction. We learned that nuclear fusion in the star's core transforms hydrogen into helium, releasing energy that creates an outward force known as radiation pressure. This force counters the inward pull of gravity, which tries to collapse the star. Understanding this balance is crucial for comprehending how stars function and evolve over time, highlighting the importance of fusion and gravity in the life cycle of stars. Watch the rest of the GCSE physics course at Sophos Education.